Welcome back, everyone. So this is going to be part 2 of the first lesson. So kind of continuing on, I know we ended with talking briefly about average rate of change, or instantaneous rate of change rather. So we're going to be doing the average rate of change, but in order to make it an instantaneous rate of change, we're going to do the average rate of change, but over much smaller intervals. So as we briefly talked about previously, so we looked at the intervals of these 4 problems, and I want you to notice how small these increments are. So we're trying to get as close as possible to a specific value where we can evaluate the average rate of change. So looking at this problem, so a ball is thrown vertically in the air. For 0 to 5, the height of the ball is modeled by the function h of t equals negative 4.9 t squared plus 25t plus 5, where h is measured in meters and t is measured in seconds. Find the average rate of change in the height of the ball over the following intervals. And then you're going to include the units of measure. So they give us the equation. So I'm going to write on this little scratch piece of paper so I don't have to worry about space, because I write kind of big. So I'm doing this on paper specifically so that I can show you guys how to do some calculator tricks to make your life a little bit easier. So the first thing I want to do on the calculator is actually reset it. So before you get any quiz or test, you are going to have to show me a reset screen. So in order to reset, you're going to have to go and do menu, and you're going to go down to system. And then you're going to press F5 for reset. And then we want to reset the main memory, which is going to correspond to F2. So press F2. And then you're going to press F1 to confirm. So this is the screen that you're going to have to show me in order to get that quiz or test. Okay, so once you reset, now I'm going to go ahead and begin. So you can do this the old-fashioned way. You can go to Run Matrix and just plug in your values. So we need to find the average rate of change at just 1 second. So if I just do it the good old-fashioned way using function notation, I can do negative 4.91 squared plus 25. That's 250. I can't type. Everything's fine. I got sausage fingers. So plus 25t and then plus 5. So we get 25.1 for h of 1. But now we need to evaluate h of 1.1. So doing this, I'm actually going to do it a little bit differently. So to do this a little bit differently and what I think is actually quicker, I'm going to go to menu, and I'm going to go down to graph. When you go down to graph, it's going to pull up the graph function menu, and you're going to type in your equation. So instead of t, we're going to just type in the variable x. It's all going to mean the same thing. So negative 4.9 x squared plus 25x plus 5. And then once you finish typing it in, press execute, and then it should be the same color as your y value. So once you input it successfully, the whole thing should be blue. So in order to see a picture of your graph, then you're going to press draw, which is going to correspond to F6. So if you reset your calculator, then this is going to be the standard view. So I need to look at my parabola and I need to go up. So in order to adjust the window, you're going to look for V window, which is right here in gold on F3. So I'm going to press F3, and this is your view window menu. So the X values are fine. I don't need to go left or right. I need to adjust how high up it goes. So with that, I need to adjust the Y min or Y max. But I'm going to adjust the Y max so I can go up. So I'm going to change this to say 20, and then press exit and then back to draw, just to see if that gives me a better view. So it might be trial and error. That is perfectly fine. So another neat little trick about the Casios, you can also use your little toggle pad right here, and you can press the right button to toggle right. You can also go up, you can go down, and you can do your window adjustment this way if you want to. Another nice little feature is the plus and the minus sign also double as zoom features. So if you press the plus sign, it will zoom in, and if you press the minus sign, it will zoom out. So those are some nice little features. So I just manually adjusted my window. So now that my entire graph is in the picture, I'm good to go. But if you want to do a view window kind of adjustment, then you can just manually adjust the values from here. So I'm going to do like -5 and then up to 50. And then for my X values, I'm going to go back and do like -3 up to, I don't know, let's just do 10. So that's a great view. So once you get here, once you get a good view, now we're actually going to evaluate at specific points. So if you look in gold, the button that corresponds to F5 is going to be G-solve. This is graph solve. So I'm going to press G5, and then these are all the different attributes that we can actually solve for on your Casio. So you can actually find the roots, which are your x-intercepts, the maximums, the minimums, the y-intercepts, and if you have multiple graphs, you can even find where they intersect. And then if you look over here, this triangle that corresponds to F6, this means that there are more options. So if you press F6, you can also do a y-cal and an x-cal. And then this right here is integration. That's for calculus. We're not going to worry about that. At least y'all won't have to anytime soon. So what we're going to do is, we're actually going to go back over here and explain these. So a y-cal, what this means is you're looking for a y value. So it's going to prompt you to enter an x value, and then it will give you the corresponding y value at that x value. And then for an x-cal, it's going to prompt you for a y value. So you type in a y value, and it'll give you the x values when that happens. So for example, over here, so for this problem right here, I'm given an x value, and I want to find a y value, which means I want to do a y-cal. Oops. So go back and then press F1 for a y-cal, and it's going to ask you for an x value. So I'm going to type in 1.1, and then it gives you the value 26.5, not 26, that's just 20. I'm blind. I can't read. That should just be 20. So whenever this happens, what I like to do is adjust the window again. So like I'll adjust it to like -10, just to give my window, whoops, it is 26. Just to make sure. And 5, 7, 1. So now that I have both of these values, now I can actually calculate the average rate of change. So to do the average rate of change, so I'm going to be doing h of 1.1 minus h of 1 over 1.1 minus 1. So when I plug in, this is going to be 26.571 minus 25.1 over 1.1 minus 1. So now I'm going to go back to my calculator, go to menu, and I'm going to go back up to run matrix. So I'm going to clear this. So I don't need this anymore. So you can press F2 to delete. And I want to delete everything that's on here. So I'm going to press F2 again and then delete everything. Okay, so in order to type in this expression here, I want to start off by opening up a fraction. So you can open up a fraction bar by pressing this fraction button that's right above 7. So then I'm going to type in 26.571 minus 25.1, and that's going to be over 1.1 minus 1, which is going to give us an average rate of change of 14.71. And then our corresponding units would be meters per second. So that's what I'm going to write over here, 14.71 meters per second. So now I'm going to do the same thing for B, C, and D. So I would actually invite you to pause here and actually find the average rate of change for these other three on your own and actually practice using the calculator. All right, so I'm going to go ahead and go on. So we need to evaluate at h of 1, which we've already done. We know it's 25.1, so I'm going to reuse that information. And then I need to evaluate at 1.01. So we're going to make this interval smaller. So I'm going to go over here to my calculator, go back to graph, draw. So G-solve, and then I'm going to do a y-cal, and I'm going to type in 1.01. So my average rate of change is going to be 25.25151. Now, I'm going to keep all these decimal values just because I want my average rate of change to be as exact as possible. So I know a lot of people want to round to like 2 or 3 decimal places. For AP pre-cal purposes, you're always going to round to 3, but I would not suggest rounding until the very end when you get the final answer. So in order to find that average rate of change, so we're going to do h of 1.01 minus h of 1, and that's going to be over 1.01 minus 1. So this is going to be 25.25151 minus 25.1 all over 1.01 minus 1. So then you're going to plug this in. So I'm going to go back up to run matrix. So fraction, so 25.25151 minus 25.1. Ha 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 ha, sausage fingers. So 25.25151. There we go. So that is going to give you 15.151 meters per second. So notice how we started off with a slightly bigger interval, when I say size relative. So we got 14.71 meters per second. Now we're going to 15.151 meters per second. So now let's do the average rate of change again with an even smaller interval and see what our number is. So once again, I'm just going to start with h of 1, which we already have. It is just 25.1. And now I want to plug in and do h of 1.001. Let's see if I won't mess this one up. Okay, so back to menu, graph. So shift, gsolve, toggle, ycal, 1.001. So that's going to give us a value of 25.1151951. So I know it's a good amount of decimals, but that's okay. So your average rate of change. So h of 1.001 minus h of 1 is going to be 1.001 minus 1. So when I write it out, so 25.1151951 minus 25.1 all over 1.001 minus 1. So menu, run matrix. So 25.1151951 minus 25.1 all over 1.001 minus 1. So now we have 15.1951 meters per second. So if you look at the previous value that we did, we got 15.151. Now we're getting 15.1951. So we're starting to kind of level off. We're starting to get a consistent value. Whoops, I didn't write my values over here. Okay, so for B, it was 15.151 meters per second. For part C over here, 15.1951 meters per second. All right, and now let's look at part D. I don't know why I wrote part D and I didn't write A, B, or C on the others. That's fine. So now we need to evaluate h of 0.999, which this one was not given to us, so this one we are going to have to find. So back to graph, draw, ycal. So type in 0.999. So we're going to get a value of 25.0847951. And then we already know what h of 1 is, so I already know that this is going to be 25.1. So now I'm ready to do the average rate of change. So that's going to be h of 1 minus h of 0.999 over 1 minus 0.999. So this will be 25.1 minus that long number, 0.847951 over 1 minus 0.999. So this average rate of change, let's see what we get here. It should be pretty close to 15.19 since we're getting closer and closer. So 25.1 minus 25.0847951, 1 minus 0.999. Yep, so really close to 15.2. 0.049 meters per second. So up here, so this is going to be 15.2049 meters per second. Okay, so I'm going to get rid of this. All right, so as you can see, as the intervals got smaller and smaller, we're getting really close to about 15.2. So if I round this to the second decimal place, it's 15.15. Over here it'd be 15.2. Over here it'd be 15.2. So we're getting pretty close. So if I had to justify and say what is the average rate of change at 1 second, I would say the average rate of change is going to be about 15.2 meters per second. About. And then the reasoning that you would write to justify would be as the intervals get smaller, the number or the average rate of change gets closer and closer to 15.2. So that would be your verbiage that you would write, which I'll let you write it in your own words. So, gold star, ta-da!